Okay, so we are now recording. Go to screen share. And I want this one. All right. Now, how all this is going to work with the magnifier, I don't know. Quick review. It all works now. So when you log into the Jupyter notebook, you get a screen like this. You put in your first name and your 6-digit, your password, and it signs in. And it brings up the Jupyter lab, wherever you left it, okay? That looks funny. And I'm going to type in exit here. And I've been playing with the settings to go between dark and light. Dark is kind of nice for the terminal, but the text file, you can't see anything in the text file because it's black on black. So when I use the text, I'm going to have to go to the settings white. So for the time being, I'll use light. And what this allows you to do, we are going to spend most of our time with the terminal. Okay? And I will show you what Markdown is and why you want to learn it. And this is, you have some files in your public HTML directory. Okay. So you can navigate around and notice here, I double click. This is the file I just created. Okay. Now I do want to mention one little thing about how this web part works is the only thing that will display on the web by way of this long gnarly URL is stuff in public HTML. So if you put something in the ASM and you want to see it on the web, it won't work. You actually have to copy it or symlink it to do that. Okay. But this should now work using the name jnkll.org from on campus and off. They fixed it, I think, last night. And in the good old days, they were doing DNS shenanigans to make things work. And now what's happening is that it resolves internally. The 11 address, there are 10 dot, goes out on an address, and it does a U-turn, and it comes right back into the firewall. All traffic is logged, which is why you why does it take so long? Well, it's going all the way out and back in again. So they're doing this for multiple reasons. They are tightening down the network across the board. Two-factor authentication is coming to your future. We're going to have that. It might be MFA. It's probably going to be more than just 2FA. But anyway, it's coming. And this is what we'll be doing. Okay. I will show you other ways to access the box as we move along in time. And one of the things I would like to experiment with is giving you guys some virtual machines to play with. Okay. And I've gotten pretty good at converting virtual machines to different platforms. And VMware, I don't know if it's included in VMware Player. But if we create a virtual machine in Player, we can convert it to KVM, which is what we run on. That's what I run on everything. KVM is fast. Okay. All right. So let's look at some tools that you get for free and what we'll be talking about. Okay. I have this should be in a bulleted list, so my markdown is incorrect. This is called the Simple as Possible Computer. And this goes way back to the dark ages of, I don't know, 1993 or something, 93. What this does is this reference. You I think it's the end of it. You actually create a real computer using very minimal, there it is, SAP2, simple as possible computer. If you can wrap your brain around what this is doing, you get a really good handle on assembler. And computer engineering will be in your future if that's what you so desire. And this is, they talk about the architecture, what kind of instruction set it is, and so on and so forth. It somewhat mimics that book I showed you, NAND to Tetris. This predates this by quite a bit. Okay. All right. So that's one of the books we'll play with. This is what we will be talking about today. When we talk about assemblers, we have two of them. Well, there's a gazillion of them. This thing called AS. It's referred to in print as GAS, and then NASM. Okay. The GAS stands for the GNU assembler. This particular assembler is agnostic as far as what chip you write your assembler code to. That doesn't always. Years ago, you had an assembler for this chip, you had an assembler for this chip, you had an assembler for this chip, and you had to learn different assembly languages based on the chip that you were using. In today's world, there is this universal assembler. But there's a directive across the top saying, what chip are you using? And it generates all the machine-specific instructions. Okay. This one uses one style of format. It's called the AT&T format. And then NASM uses the Intel format. Okay. And I will show you examples of what the code looks like and what it looks like differently. Okay. So we will be playing mostly with the AS assembler because it is part of the GCC, C++, or G++ tool chain. It's all part of the GNU suite. NASM, it's out there and it kind of sits out on its own. And you got to make sure you get the right versions for the right Intel chip. And it only does Intel. Well, it will do anything that is i386 or x86 compatible. But there's going to be things like in some of your MIPS languages or MIPS chips, you can't use NASM. All right. All right. Now let's take a look at how this works. Here's examples in this article are created using the AT&T assembly syntax. Okay. Why do we use it? It's compatibility with the GCC. Okay. It's inline assembly. It's kind of how it works. NASM uses a different syntax. Okay. AT&T standard on Unix and old school NASM as PCs. IBM, PC, AT, XT, all those ancient machines that you no longer find anywhere. Okay. So the move instruction have mnemonic source and destination. So this is the source. This is the destination. So if I'm going to move, it goes from here to here. Okay. And NASM, so if it goes move left, So here, what's going on. These different registers, what are they for? I will talk about how all that works. But the best way to think of these registers inside of a computer is if you loosely correlate registers to a cell in a spreadsheet, and you put different stuff, and then you move it out of that cell into something else when you get the result. It's not a really good fit, but basically what you're doing is you have a register and it has a name. In this case, E Echo Baker Paul, and then you put stuff in it, and that register has a special purpose. It can be a pointer or it can be an accumulator, but registers are specialized, and there's a few general registers. Now, how deep are we going to go on this? Enough that you understand what you're looking at when you're using the debugger. That's what we'll be working. Okay, that's our goal. Okay. And what we'll be doing is today we'll be kind of doing this. We will take our code. Remember, we did this already. We did this last week. And we run it. We've got the object code, but there's a flag that allows us to generate the assembler. This is part of the reason we'll be using the AS assembler versus NASM, because the GCC puts it into this format. Okay. And back in the day. And then what happens is, remember how we did the compile line right here? We did that, or something similar to that. All right. And then it runs and prints hello world. And then this is saying, I can make that bigger. Let's compile this and use the uppercase S. It's a special flag. Okay. So it builds the source in AS. Okay. And we're saying N32 to give it a 32-bit source code. So you don't have so many big old zeros to look at. Okay. Now remember, NASM started back in the day in 8 bits. And then Intel went to 16 bits. And then, oh, great breakthrough. We had our first i386 chip, and it went to 32-bit. And now we're on 64. Now RISC has got 128 and some even more. Okay. All right. So what ends up happening is it takes the C source code and it creates a file. Okay. And then this is showing you how to compile the source code and then how it runs. This is what the source code looks like with those flags. Okay. Doesn't that? Yes, I'm going to be able to read all of that. Maybe, maybe not. This is debugging. Now, what happens when you bring your source code into the debugger? Often, depending on where you are in the debugger, this is what you're looking at. Okay. So understanding how this debugger works is kind of what we'll be doing. We'll have several exercises using the debugger. We will be taking some source code in C, and we'll create a header file, we'll create a function file, and we'll put it all together, and we'll trace it through the debugger so we can see the symbol tables and we can see what's actually happening to our code as it's running. Okay. All right. And then these are for directories for debugging. If you leave them out, debugging symbols, you cannot debug using the debugger because the debugger has nothing to hang on to. So when you compile, generally you include debug symbols until you're ready to push it into production, and then you turn the debug symbols off. Okay, because they're bigger, they take up space. So far, there's not been a lot of exploits on leaving debug symbols in. But your boss will tell you what they want you to do. Okay. All right. So we're going to go through this, and this is kind of where we'll start today. We'll have some fun with it. Okay. So where is this? This is right here. Oops. Move over one. This is in Canvas. So if you log into Canvas and you go to other notes and such, I'll show you how to get to it from Canvas. Click. Open a new tab. There it is. We are going to use this last one. I need to fix the page, but there's 3 links here. Okay. We're going to start with this one. Okay. This is a wiki book. Okay. So for some hands-on stuff, we've already done this, right? Everybody remember how to do that? Okay. Let's go do it again, except we want to add this. We want to play with this stuff. Okay. Now we can get there a couple ways in our Jupyter lab, and we put that in assembler, right? Is that where we put them? Nope. Where did I put the code? I don't even, oh man. I know I put it somewhere. CPP, I think. Yeah, all right. Thank you. There it is. All right. But I need to open a terminal there too. So let's do that. I'm going to open a terminal, and notice it's already in my CPP directory. Do ls. There it is. Okay. And I'm interested in hello world C. So I'll put a few commands that we're using. We do cd ls, which means list, and then the word cat for concatenation, hello.c, and that's what we display. And now we're going to compile that, because I don't have any other file there. So I want to take this and just click. Well, let me do that. That's interesting. Okay. Okay. Now let's explain what this is doing. Compile, make bigger. Move it over. Compile a GCC, take my C source code, output it, make the run file that I'm going to turn my object code, my executable. I'm going to call it high W. I'm going to use the standard C99 version. And then I put a colon in there. It's a semicolon. That's the same thing as typing return and then typing ./HIW on the next line. This is the way you put 2 commands on one line, is you use the semicolon. That's all that does. Okay. So you can see there it goes. Now I pop over to my wiki book here, and I want to do this one. Now let's do like everybody does. I'm going to copy some code and I'm going to paste it, and it's going to work, right? It's going to work, right? Why'd I get the error?
Because it's hello, not hello world.
Bingo! It's hello_world.c. All right. It's the simple things like that that will bite you the hardest. Your entire career. I spent, I think it was last year, I spent 4 hours working on this problem. And I had the slash going the wrong way on one command switch. One stupid little, I go, wow. But I had been working on Windows for like 4 weeks. So it's like, eh. So I want to change this to what I have. And now if I do an ls here, you see a new file? What's the new file? .s. And what's in there? Let's cat it to the screen. Wow, looky there. That's my assembler in gas format. So what I will do is I'll bring it up in the editor they have here. There it is. Double click. And now it comes up in this editor that I can look at. So let's talk about what this is doing. All of these things mean something. And rather than just smash your brain full of all what everything means, and then you forget it, we'll learn it as we go. Okay. We'll talk about things as we move forward. Okay. There's a few in here that are really important, like .file. Okay, that's telling you where the code is coming from. This is the .s file, right? So we use the .c file to generate the s. And the s has the original C file in it, or the name of it. So what if you renamed hello world.c? Would it still work? We're going to experiment. Okay, we're going to tinker. Okay, and text. And then these sections, they talk about that in this part here. Okay, and we just did it for 32-bit. Now you will see that we have some subtle differences here. There's the LCO file, def, and this hello world. What's this? 12. What did we have there? Does anybody know what the default is in Windows for a carriage return?
Is it that what we're looking?
Is
Is
what?
that what we're looking at?
No, we're looking at a pure Linux right now. This is Unix. Unix only uses /n for the carriage return. In the early days, you can still see this. If you take a Linux file and you put it on a Linux file on a Windows box, you'll get a bunch of little black boxes in it. You may know what those black boxes are? It's a carriage return line feed combination. When they terminate a line in Windows, it's, and I always forget which one's first, RN or NR for the carriage return line feed. But in Linux, we only have N, which is 0A, okay, in hex. 0A. So moving your data files between systems, you used to have to convert all the trailing line feeds to your target machine of choice. You will still have that problem. It becomes a little more obscure, but you will still have, why is this displaying so funny? Why are my spaces all off? That's why. Okay. And in the world of Macintosh before they stole the FreeBSD kernel, they used only the R. So you had even yet another conversion to happen for straight text. Okay. All right. Now, as we move down here, hello world text. Here we have a global. This is important right here. We have something called an entry point. When we run a program, it loads into memory, and then it looks for a certain symbol or a flag, I guess you call it, a symbol, saying, okay, this is where I'm going to start the program. And then it loads it in RAM and actually does stuff. Okay. So, all right, everybody, go do that much. Take your Hello World C that you've already done your homework on and do what I just did. Okay. And where's my terminal? Here it is. So what did we do? Hello world _C is in your C++ directory, I believe. Yeah. So open a terminal and go to that directory and type it out, so do this. So I'm teaching you some Linux, whether you want to or not. But this is knowing what your stuff is something that's really important. Okay. Once we compile it, you run it, and then do that. Except do it right. Okay. Now, do you suppose, making an intuitive leap here, I could say G++ uppercase S and get some assembler code? Safe bet. That's next. So what we're doing is we are using the compiler suite to create a run file. Then we use the compiler suite to generate assembly code. Then once we have our assembler code, I'll show you how to assemble it. Okay. Now, these little steps, you need to practice them to remember the order. Or if you're a good note taker, you write them down somewhere. I find if I write something down, I remember it a whole lot better. If I type something in, I don't always remember it. That's just neuroscience. Okay. Now, so do that. And then I'm going to do the same thing. I'm going to take that line. And I'm going to try something here. I don't think it'll work. It might. I think it will overwrite my hello world S. So let's do that first. Hello world 2. I'm going to follow the same steps I just did. Change it by. That yellow is terrible. I know, it's really cold in here. Hi world is fine. Hi world is fine. Hello world 2. So I'll have a different string to look at. There it is. Go back to this. Now I was doing an LS minus L on that. In reverse sort order by time. I'm looking at the site. You can see that the source code isn't very much different in size. That makes sense. This is my C object code. And this is my C++ object code. Here's .s for the C. And here's the .s for C++. It's a little bit bigger, right? So let's look at that one. Go over here. Probably that one right there. Hello World 2. Let's take a look at that. Well, it's got a lot more noise in there, huh? A lot more information. Is C++ a little more complex programming language than C? Yeah. Orders of magnitude. Okay. So do those two things or three things or whatever we just did and get these generated in your C++ directory and make some notes somewhere. And remember, we have this lovely thing called history. Did I show you that last week? Oh, that was for the Linux class. Sorry. If you type in the word history, it shows you everything you've been doing. So it's a great way to take notes. Yeah.
Does it survive restarts?
Yes. It maintains state. The thing that makes history quirky is it's held in RAM until you log out. So if you have two or three sessions open and you're doing a bunch of different things, it's going to save them. But you have to log out of all those. Okay.
That's what set your buffer.
Pardon?
You have to also set your buffer.
Yes, you do.
Sometimes you might have it set really low and you
Yeah.
won't have much history.
Yeah. I set my buffers for the shell history really, really huge. And then every now and then I'll go through and remove the duplicates and then create little cheat sheets on certain things that I need to do over and over and over again. Okay. Works really well. Okay. This is what we've been doing. Now you do not have to use the VI editor to edit your file. You can use the editor that's part of the Jupyter Notebook, Jupyter Lab. Okay. Everybody got that? Everybody got their .s's? We're good. You have your C++ and your GCC. Okay. So basically, we're reinventing what we did last Thursday by compiling source from the command line. And we're doing the compile line. We're giving it one extra switch here to generate assembler. That's what this is doing. So we're gonna have assembler code. All right. So go ahead and work on that. I'll give you a few minutes. that over here. Now that we have some assembler source code, what do you want to do with it?
I'd like to compile it again, but make it unified, efficient.
You betcha. That's where we're going. We are now going to learn what the next pieces of the process are when you have assembler code. In a compiled language like C, and the simplicity that we have, it goes from human readable source into an executable format. Done. Assembler does not do that. Assembler does just that. It assembles your code to something called an object files.o. And then those objects need to be linked in order to create an executable. And all that's done transparently with the GCC tool chain. Because the way the GCC and the GNU tool chain works is it takes the C source code, converts it into assembler, and then compiles the assembler and then links it and makes your executable all in one big fell swoop. This is why you can take your C source code and generate the assembler so easy with just a command line switch. Okay. They call it this, the AS is kind of a generic assembler that will work pretty much across all platforms. Because there's a lot of deep computer science that happened over many, many decades. The company that wrote GCC was a company originally, they were called Sigwin, if you've ever heard of them. And they were going to do an IPO. And I said, man, I want to get on that bandwagon. But then Red Hat bought them. Nuts. That was many years ago. But Red Hat is still the folks that may help maintain the Sigwin tool chain. What's the Sigwin tool chain? It's all the Unix tools you're familiar with, but it works on Windows. Okay, that's what Sigwin is. And I use this Moab X term I've been showing you. That's all the Sigwin tools. Okay, so if you can't find the C compiler for Windows somewhere, you can load up Moab X term and type in GCC and have it install it for you. Okay. And if you're interested in that, I'll show you how to do it. Okay. All right. So, all right, let's see here. Let me go into this next thing. Previous, next. LD. Do that next. Okay. So now we're ready to take our assembler code and assemble it. And we will do that with our C assembler first. So we'll use our hello world.s first. Okay. And the way this is, we'll start, we'll say AS. And then we'll, just like before, when up here we have an O, what's the output going to be? I'm going to leave it off for the time being and simply type in hello world.s. Oh no. What's going on? I'll show you. It's still going to be there. It's hello world 2. Still getting that. Oh, the flags for the 64-bit, 32-bit. Let's recreate this. Let's use the hello world one. That one. Okay. Make it 64-bit. Now, when I do this, see what we get. I'm trying to make it as simple so I don't have to go into a gazillion flags to make it all work. Magic. What I do. Let me explain. I tried to assemble. When we did our first GCC line, we did it with M32. Right? It worked. It gave us an S file. 32-bit. What's our machine? 64-bit. So I did it again. And what did I do? I took off the -M32 and it generated a new .s file that looks like this. Boy, that looks terrible. Why did 64-bit? Okay. And then I simply did this. Assemble my hello world.s into whatever it is. Now, in C and C++, I think even Fortran and a bunch of others in the AS, when you do it this way, without this -O, okay, A.out is what you will get. So if you type in GCC source code.c, hit enter, you get A.out. Now, will that A.out run with GCC? It will. Now let's do that. I'm going to go back a few steps here. And I'm just going to compile it. Boom. And if I do, there it is. There's my A.out. But before I do anything with it, I'm going to use a little bit of an inspection tool called file. Okay. A.out. And it's going to tell me what it is. Okay. Says it's not stripped. It's executable. All right. Tell me what it's done. Gives me a unique ID. So I can type in ./A.out. And what am I going to get? Hello world. So why did I teach you the -O to make it like hi or whatever you want to call it? Because if you're working in a tool chain and you're doing an assembler and you're doing some C and you're doing some C++ and you leave the -O off all your files, every time you run something, what's going to happen to my A.out? It gets trashed. And now let's do a file on A.out again. Oh, wow. It looks a little different. Now, can I run it? Oh, let me change permissions. Oops. Yep. Because there's another step. In assembler, we assemble and then link. Okay. Because generally, when you're working on assembler, you may have 35 different assembler files and you're working on this one. But you need to link them all together to get your program to work. Okay. So this is the toolchain stuff that is part of all the programming. And yeah, it's kind of crazy, but this is a lot of magic happens and you don't have to mess with it too much. So we have to figure out, okay, let's do this. I want to give it a -O, and I'm going to call this hello _ ASM, just so I know it's going to be different. Okay. I'll do L1. That's mine. So there it is. I'm going to remove the A dot out just to say that. So now I have this. What's in it? Well, we'll do a file. Tells me, whoops. Hello, ASM. It tells me relocatable, not stripped. Well, let's look at it. Let's use hex dump. -C. And pipe it to less. Why do you make this a little bit wider so we can. I guess this is wide as we can go. All right, time to pop on another way. That's what's in the file. Okay. But now that we have this file, these are all the things we've been working on. Okay. We got our S and C and this is my new and improved assembled but not linked. Okay. So everybody do that, get to that point. And I'll bring up my shell history so you can see what I did. Well, it's not on that one. Let me go back to here. Oops. So we generate our S file. We assemble it. And if we leave off the -O, we end up with A dot out. That happens with C++, that happens with GCC, that happens with assembler. Okay. And you'll see A dot outs, and they're going, oh, they forgot some flags. So when we run it like this, we have assembled it, but we have not linked it. Okay. Ready to move on? Next step. Okay. Now, the linker is the next piece of the puzzle. And this part, I don't do this very often, so I often, oops. Let's see here. LD. And just for fun, I'm going to use this hello ASM all by itself. I've got an object, but I can't link it. What happened? What's it saying? Undefined reference to puts in function main. Why is it saying hello world C when I am in my .s assembler? I guess where it all came from. It started with the hello C, and then we turned it into assembler, and then we assembled it, and now we're going to try to link it and it didn't work. All right, now this is a perfect place for you to do this and go Google it. Because you're going to be doing a lot of that when it comes to assembler. You're going to have to go figure out how to learn, but you have to learn how to ask the right questions. So now the question you're going to need to ask Google is, I have an assembler source file and it's assembled. I need to link it, but what do I need to link it with to make it work? Okay. So go look it up and see what you can find. And then work with each other on this. Because this kind of stuff, we are covering a ton of little things that you've probably never done before. Okay. So this is a lot of new stuff coming at you. So you need to take time to do it again and play with it and teach somebody. Yeah.
May I regurgitate what the AI has told me?
Sure.
The warning message you are seeing is from LD, the linker, and it means that it couldn't find any entry symbol called _star. This is because you are using main as your entry point instead of _star. You can use the label _star instead of main for the ELF entry point. Main implies it's like the C main function, but this isn't even a function. Example given, you can't RET.
Everybody follow that? A little bit not.
Did I parrot the AI correctly?
It's that's basically, you've got it right. So let me show you the S file here. When we use assembler, we use lots of little pieces of assembler code. And they all cannot have main in it because it doesn't know which one is main. But when it has a start directive in there, you can put them together and you can link it and say which ones you want to run it by which order. So can you change it and see if it works? Try it. Use ChatGPT. I highly recommend you learn how to use the AI agents because that's the future. Everybody's going to have an AI agent by their side helping them. Microsoft and Chris has just gotten approval with the GitHub. The GitHub uses Copilot with the AI agent inside of the GitHub classroom. And eventually we'll be moving more to that. And I even found a VI add-in for Copilot.
Good.
Yeah, I go, yes, I want to learn how to use that.
If you are at MJC, you probably don't have any money. And if you use Bing, you get it free. But if you use Copilot, you probably have to pay for it.
Well, not for GitHub Classroom.
Also, yeah, if you use your student email on GitHub to sign up for GitHub or just link it to your account, you will get a bunch of different offers for free like credit on DigitalOcean, $100 for a whole year, valid for a
Wow.
year. You get all of the JetBrains editors, which are really expensive if you're
Yeah,
working
for
in the
commercial.
industry. Yeah, it's basically $1,000 per year per different editor, but with a studio, you're just offered all of them because they want you to learn.
Yeah, and Chris
whatever one.
just got our
But they're
institution.
great.
You have to have your Git repository public, or can you do it private?
No, you can have it private. That actually, because you have a student email, the whole offer is giving you GitHub Premium, like their paid for service. So you can have unlimited private repositories.
That's so cool. That's The GitHub Classroom is now a part of MJC. Chris
That's
just this semester got it rolling. Because eventually we'll be doing more of that kind of thing where you'll write your code and you'll push it up to GitHub and run it through the test. And then how well it did or didn't pass the test is how you get your grade. That's real world production stuff. ZY books and what we're doing here, this is not really that real world. It's, yeah, we're learning about it, but it's not real world. So, yeah.
So when what I was gonna have was maybe saying you have the co-pilot and stuff, how long do you get? Just for a year or what?
So it's usually every 2 years you have to reapply a report. Just reaffirm that you're still attending at the school. So they want to make sure that you still are here. So they might ask you for, you know, like your student ID, a picture of it, or a scan of your transcript, or something with the official MJC letterhead that has your name on it. So 2 years. JetBrains, they get kind of weird sometimes, and you have to actually apply through them, even though it's still linked to reapplying, because they don't trust our domain. People, I think our domain for email was compromised on a admin account 2 years ago, so
It's worth
got
it
on
to,
the list.
definitely worth it to keep your .edu email address because it gives you discounts on CompTIA certs. You get a lot of free stuff. So it's worth it to keep it active. You know, take a hiking class here or a swimming class and keep your email address active. Okay. So going back to this, we're going to figure out how to fix that little problem. And there's a couple different ways to approach this. We can use the AI agent. And the other thing is you can highlight the error just as it is, and then put that into Google and see what you get. And it will show you. Now, some of the books that I have they walk you through this, okay? Yeah. That's basically, oh yeah, that's right. The NoPy. Forgot about that one. There's always another way. There's always 10 ways. Let's see if this works. I don't know where it should be. It probably needs to be at the end. Oh, entry main. Okay, I'm on the wrong version of. So let's just edit it. And one thing we didn't mention is in this information that you're looking at, the dot name is an assembler directive. In other words, it tells the assembler to do something. Okay. All right. And yeah, ran into this last semester. Yeah, you can cheat GCC to link for you.
Is something AI can help with?
CMake actually worked for assembly in Linux at some point, just for that.
Oh, pardon?
I said, I think I got CMake to do all.
Oh,
of
yeah.
that for me.
We're gonna get into make files. And make files are their own thing, but trust me, they automate all this stuff. So you set up your make files once, and then you work on your code and you don't have to mess with it. But make files part is coming. I'll be showing how to build. I think I'll be using standard make. I might use CMake, I don't know.
But it's good to know the syntax though, because sometimes you might want to use a different C compiler that has different linking.
Right, and one of the things I was exploring with in the beginning of the semester is that now that I have a machine that's got some honest to God horsepower, we could actually do cross compiling. Is that I could set up a virtual machine for each one of you that is an actual Raspberry Pi. Sort of, kind of, and then you could write Raspberry Pi assembler inside the virtual machine. But that's too many layers deep, I think. We're just writing assembler from C, and we're going to keep it a little simpler. But I do hope to get more into the virtualization arena, because that way you can leave here with a VM and you'll have all your assembler stuff in it. Okay. That would be kind of nice. Just from
Especially when ARM is taking over like a major portion of the industry.
yeah, because the virtualization is something that you will have to know. I don't care what your job is in IT, you're gonna have to know about virtualization, Docker, Podman, whatever you want to call it this week. This, not so much. Okay. And if you are writing hardware drivers and you want to make your TCP/IP stack faster, oh yeah, definitely.
No one will expect you to run Qubes OS, but they.
Yeah.
See what a hypervisor is.
That's right. So let's go in one of my books. I've got that. Got this in here. Problem is this book, I just got this book and it's an awesome book. And I try to display it as it is a huge PDF, and it makes
What's the book called?
it makes it it's the typeset. That's what makes it so big. And what happens is it Google times out, Firefox times out, all my PDF readers time out. So I'm going to convert it using Libra and then use the Caliber book reader. Yeah. Let's see if I can find it in this book. Name, no. Okay. Yeah, he's showing you the how to do the optimizations.
A lot of PDFs time out, it's because they're using 1.4.
Yeah, there's
You just need to update it past PostScript, and it won't do that.
yeah, there's a couple ways to solve this problem. I'm trying to oh, I know what I could do. I've got that one. That'll work. This one's actually kind of a fun book to play with too. This middle one, programming from the ground up. This is actually well crafted, and it starts off in the very beginning. It says, okay, here's your code. Now let's go figure out what we're doing with it. Okay, and it talks about the tools. And we'll get into more of that stuff later. Here we go. So this is a, oops, I guess I should put it on the screen so you can see it. This is a super simple program that all it does is exit. It returns an exit code to the screen. Okay. And this is using the same kind of syntax But notice right there. That's what the AI agent is telling you. Notice the code that we have says main, right? So what if we take our code and just put in underscore start? Can it work? I don't know. Let's try it and see. This is how you remember. Okay. The flat forehead syndrome. So I want to change this to underscore start and go over here to main and say underscore start. We'll see if I get another whole screen of errors. Oh, different. Oh, that's size expression for main does not evaluate to a constant. Okay. That makes a lot of sense, doesn't it? Change that to main start to. I think we actually need to, when it generates the .s file, there's a lot of noise in there that we could go in and clean it up a little bit. I'll probably still get error, yeah. I still get my errors. So we're gonna fix that. Oops, where are we going? Where'd it go? There it is. Search for that underscore start. Yeah, good. So make is going to be next week. And that's just global start. I think it's a function. O and then LD. Yeah. Yeah, let's use this piece of code. It's so much easier. This will give you the ability to and here's the cool part is that I can actually create, I'll put this into the ASM directory. And I want to do a new file. Simply going to be exit. I'll call it txt to start with. This. Let me use VI. Yeah, folks. What was I telling you earlier about this?
Saying Windows uses a different carriage return versus Linux.
That terrible looking. I don't want to go fix that.
You know who does?
And I'll figure out another way to do it. There's another way to do it. Because what I'd like to have you do is get the assembler to work. So let's just do it that way. Go to that book that I just showed you, this one here. Canvas, the website, and then you go to that middle one, programming from the ground up. I'll fix that. And then scroll down to where you see that piece of code and type it in. Okay. You don't have to do all the comments. Okay. So I'll show you what that means. So all this stuff is comments if it starts with a hash. So you can start right there and type that in. Obviously, you're not going to type in the chapter heading and here. And that is global. Is that a 1 or an L? Couldn't tell you. It looks like an L because that looks like that. Ooh, that's kind of messy. Well, anyways, so you have like 8 lines to type in. Okay, these are all comments. Let's type that in. I'll do it one piece at a time here. Text and then go to Windows. Like cut buffers don't work the same. Now, how many would like to go back into the dark ages and actually you get a hard copy printout of your code and you have to type it in on the machine that you can only get access to on campus? Well, we're not too far away from that, but we do have some better tools. So what I'm going to do is just type it in just because it's not that far. And I have this code laying around somewhere else. I'm doing this also to freshen my memory. Book section.txt. I think that's an L. Is that a move L? A move L?
If he's saying go late.
I'll use
There's
the.
an L before or after the D in.
Oh, I did.
Global. That's what they're pointing at.
Oh,
Oh, oh.
good. Yeah, you can help me fix my typos.
Does copy and paste not work?
Yeah, it might work for you.
Roles.
I've got too many different tools installed.
In VI, it's not called a copy and paste.
Yeah, the copy, the set mouse mode.
Oh, yeah, you could do that, yeah.
Yeah, I've got the mouse set to regular, so it works more like Windows, but the thing is, you can use the middle.
Yeah.
Yeah, you can use the middle mouse button to paste on Linux. Middle mouse button doesn't always behave in
It depends
in
on
Moab
the
X
terminal
term,
you're
yeah.
running, and then VMware VI is trying to go over that.
Yep. And that's it. So we basically have what, 8, 9 lines here, and each line means something. I'll let you read through what that does and what it's doing. In essence, all this is doing is running an exit code of the previous command you just ran, okay? And I'll explain what exit codes are here in a second. And now I use this line. I say AS and I say exit dot S dash O. And now I give it the object. And notice this very last line. This is the linker line. Okay. Whoops. I put a dot in front of it. Oh, well. Who cares? No such instructions. Start.
Is line 3 wobble? Is that correct?
Oh, guess what? I forgot.
Or what? The end?
Folks, this is why we type code in. Those little problems like that will drive you nuts. And I've made so many of those kinds of mistakes. I just look for those first. It's like I can see beginning code, and especially in Python and C++, you forgot a semicolon. Oh, your bracket. Well, how do you see it so fast? I've made that mistake 1,000 times. So your visual acuity will get very good in programming, whether you want it to be or not. Okay. Now let's see if I have any better luck. Now I'll link it. And type in exit. Oops. Oh, LS. There we go. Now there's exit and it's executable. And if I type it in, all right, let's give me a command here. LS. Not displaying my exit code. Oh, well, we'll fix that. So today we had a lot of fun going through C, compiled, ran it, C to assembler, and we tried to assemble it. We could assemble it, but then we can't link it because we end up with main, not start. Then we went through that whole process again and found some code that works with assembler and a linker using start. So what do you need to do with your hello world.s's to make them assemble and link?
Use GCC to finish the job.
Use what? You can use GCC. Yeah, you can cheat. But if we were using AS and LD, and we are going to do this, what do we have to do to change our source code?
Stuff, type it in, or I don't get it.
And what do we replace? What do we fix? What things can we remove from that other code? So that's what I want you to work on. Play with it, tinker with it, and explore with what you need to do to make that code behave and do its thing. Okay. So we'll pick up right here next week on Thursday, and we will take working code like this and start putting it into a make file. So you can understand what a make file does and what it brings to the table. Okay. So jump into reading about assembler. Remember I was talking about diligent practice? Just because I don't give you homework doesn't mean you shouldn't be practicing. Okay, if you want to get really good in them, that's all it takes. It's a lot of practice. Okay, so the computer club meeting is meeting pretty soon now. I think in this room or down in the other room, I don't know. So if you want to hang out for the computer club, feel free. And continue working. Okay. All right.
I already have a good homework, so probably you can just in the settings.
You too. Thanks.
Yeah, it'll settle, better use the account you already have. You use other GitHub accounts for code that you don't want, showing up on your professional, like history, is are going to give your GitHub account to an employer usually, just so they can see things you've written. Or you might actually be doing your work by contributing code to an open source repository for your employer. Because that's a lot of development jobs, where Microsoft,
I believe you have made the case for Copilot.
Oh, yeah.
It just pops up right on the side. The only downside though is all that registration crap. If you're in a pinch, like now you need it right now, whatever. They have a Chat GPT playground. There's a million of them that you could just drop shit in or whatever, but they all have caps or they have 3,000 character limits. So if you have a long string, but Bing doesn't. Bing, you can just jump right in, paste it. They only give you like 4 follow-up questions, but it'll track it. So if you're like, hey, fix this, you put the script in, it'll say, oh, blah, blah, blah. And
Oh, you mean the line that was wrapped? Don't, or the,
No, I meant like, so say, for example, you say, hey, Bing, fix this. And they'll say, okay, it does this.
Oh, I
And then you come back and say, it's still not working, or they meant something else. You can actually follow up and say, it's still not working. I want it to do this, and it'll correct it. It's pretty cool.
that's the future.
Well, that's just if you just like, if you're in a paint shredder, but if you have it pre-set up and you have prep for Copilot or whatever, Copilot will do it on the fly. Like
Yeah.
you think like a useful autocomplete.
Yes.
You know, when autocomplete just says there's an error
Yeah,
and you, whatever.
yeah,
Oh, also.
I agree.
I
And
know-
it's something that, using the Copilot is something I'm looking forward to. It's
On your Canvas page, you said meet with you in out of office hours to get credit.
yeah, just so I can help remember your name. That's,
Yeah, oh, yes.
How do I get credit for that?
I already know your name, so you're good. You got an easy 25.
I thought it was like, no, I gotta be in that room, and if I'm not in that room, don't have. Also,
Just help me remember your name.
the what was it? The book or I believe you had an intended textbook, whatever. Is it? I think this is the current version of it. They told us we can't take the cover off.
Oh,
Is
you
that-
got it. You're gonna love this.
Well, I was taking a look at it, and basically everybody was kind of following this flow because I guess the version you had is about 20 years old, and I guess they've constantly made new ones.
Let's see. I'm not sure what version I have.
This is supposed to be the newest.
But the nice thing about this whole book is on,
Oh yeah.
the course material is on Coursera. You can take the free class, use this book and work your way through it and get a really strong handle on building your own.
Basically
computer.
went through a bunch of books and a lot of them, either one, there's a real popular one from a guy named Randall Hyde. And the problem with him was he made his own language. So he's teaching you his language.
Yeah.
It's not useful. And that was the biggest complaint. There's a lot of schools actually using his book. So at the end of it, you learn how to use, and he called it high level assembly, but nobody else does. And that's why I was glad you did it. So I started looking in for assembler books, and I'm glad you recommended this because a lot of them, what they'll do is they'll just give you a vague how to spell assembly, what they go over your concept assembly is, and that's it. They won't tell you to use it. how to read
Right,
it.
right.
But I did find this, and I found one other book, which a lot of people skip. So there's a whole series of these. These are frequently seen as children's books or old people
Oh,
books,
fun.
but
Oh.
it's an assembly book for children. Yeah, but a lot, 'cause that's why I said a lot of people overlook these things, but if you look in these things, it actually has step by steps. It has guides, and this isn't the children's section.
That's great.
Yeah. Because usually when children, it's like, it's like somehow it always ends up at scratch.
Yeah,
But this one, no, this series was amazing. I was trying to set up understand, what is it, a firewall rules?
yeah.
And a children's book, the textbook, the actual manual, I didn't answer it, but a children's book had an example, because they knew what you were doing.
That's pretty
But
cool.
just-
Oh, did that come out of England by chance?
It might have, yeah. I think that this is a whole series they have on there.
Yeah,
But also, if you wonder where the hell these come from, the library, they
this
have,
is pretty cool.
so there's two programs on there. They call it WorldCat. If you go through MJC,
Oh, yeah,
MJC is very hostile towards textbooks.
Yeah.
And they will not do it, or you have to pay for it. But if you go to the county library,
Yeah.
Link Plus, whatever, it's free.
Yeah, I get it.
But you see, this actually has walkthroughs and stuff.
Fun.
And it's in the children's book.
That's really cool.
Because, like I said, the other ones will usually, oh, this is how you spell assembly, and they'll have an explain a zero. They
Yeah,
usually explain Manchester encoding is almost mandatory in there, and then you're like, what does this have to? And then just
All the other.
yeah, this is really cool.
They're already.
awesome.
Yep, United Kingdom.
Yeah. Organizing.
Cause I noticed that the UK has done some really remarkable things at the lower level for getting people into tech.
Like Raspberry.
Yeah, that and they've got they've got actual money going into those types of programs. And they're teaching teachers how to do this.
They I forgot what it was. It's called Beagle Board or something.
Oh, Beagleborn,
Yeah,
yeah.
yeah. It basically, they said, I guess for people that were too poor for Raspberry Pi, they went a
Yes.
step further.
Yeah.
I was looking at it, I couldn't find anybody doing it. I was
Well, there's Arduino and Beagleboard, and the really cheap one is the EP32. That one's been around a long time, and you can do all kinds of things with that little chip, and it's usually for like clocks or something small. It doesn't have a lot of horsepower, but it's a great way to get into embedded systems programming.
But is there, what it's gonna ask, like, for example, if I got stuck on Pi and something's not working, I could just walk in any computer room, there's like two people. But like the other stuff, like, what are you talking about? I don't know. Is there a computer?
Yeah, I'd say the Raspberry Pi, you just can't go wrong with it.
Are you still against using the magnifier or whatever?
Yeah, I'm gonna try to figure out how to.
Also, I'd feel bad about this, but also, I don't know how you react. If you go into the Jupyter notebook, you're a DKP user, the
Mhm.
files you save, were you wanting us to see those?
Oh,
Because
I don't care.
what is, again, it was because